genetic drift would have a greater effect in small populations like these, and genetic drift is just divergence that's more of a result of sampling error than any real evolutionary process. It's often followed by reduced heterozygosity, because if just by selection alone there aren't as many alleles, it's less likely that you would see heterozygosity. And we did see reduced heterozygosity in most of the populations, so we can't really interpret it necessarily as a founder effect characteristic in some populations, because all of the populations had reduced heterozygosity. And also it's reduced heterozygosity is an effect when drift is the only evolutionary force, and it's probably pretty safe to say that that's not the only evolutionary force in these populations, because that's not a very real world way to think about things. So we just found that the Wachusett mountain populations had more population structure than some lowland populations. Could be a difference in fitness strategies, sometimes reaching maturity faster but at a smaller size is a fitness advantage, whereas in other environments you might be able to take more time, put more energy into maturing like a body size, you'd be more fit because you could have more eggs.
But that presumes that there's genetic variation that underlies that difference in
fitness.
Well, no, physiology, right? So you just, I mean, you're right to say that it's a good strategy in some environments to grow up quick and reproduce versus take your time in others. But if it's within the physiology of the organism to just do that, to make that switch by nothing but acclimation as they grow up, then it doesn't necessitate that there's genes underlying that variability.
Right, I agree. But it does help to imply selective pressures that are different between populations. I guess is kind of what I was...
I mean, so have you thought about testing? So like, I don't know, a good follow-up for a lot of these types of ecological studies is, I don't know if you'd even be allowed to do it, but experiments, right? Like common garden or transplant, whereby you take individuals from one area and put them in, right? So you take summit individuals, put them at the bottom, take bottom individuals, put them at the summit, and then see if they are capable of doing these different strategies as you call it or not.
Sure, Scott can't wait to do that. Brings me up to another point. I didn't, if you're even allowed to do that, I didn't collect the tissues for this. iCook didn't review it because I didn't do it, so just throwing that out there, my little disclaimer. So someone was allowed to do it, that's all that matters. Sorry, I lost my train of thought. Oh, okay, and then we noticed that on the mountain, especially genetic variation was correlated more highly with habitat variation or elevation, you could say, than geographic distance. And then the similarities in the lowland populations are such that you might still see a geographic distance influence on genetics. So by that I'm saying that Milford, Westford, and Acton, which are all at a closer plane in elevation-wise, Milford, which is far away, is genetically distinct from Westford and Acton. So there's still some influence of geography, is what I'm saying. I'm not saying that geography has nothing to do with it at all. So community genetics is kind of this concept of how to treat communities of animals and biodiversity. Do we treat it at the species level, or should we start looking at a subspecies level? So if spotted salamanders existed on this gradient, on this elevation gradient, are exhibiting adaptation and phenotypes to the variable conditions there, it might give an implication of like good long-term viability of the population. So that's not something you would know by just looking necessarily at morphological characteristics of salamanders. You might only see that kind of differentiation at the genetic level. So community genetics just studies the interaction between genes within species and populations of other species of animals in a community. So it's kind of still coming into its own, but I think there are important questions that are being brought up by community geneticists, and it kind of interesting for these populations in particular, because they do have some congener species in these ponds with really unique interactions, like insect and amphibians interacting, for example. So for future work, this intraspecific or within species genetic data could be applied to the larger community ecology of the summit, or not necessarily just the summit, but all of Wachi-Tsunami, because it's such a unique ecological environment. And then monitoring conservation might benefit from studies like this. Unfortunately, amphibians are declining at a pretty rapid rate. The rate exactly is kind of debatable at this point, but you can see this is 1950 down here, this is 2000 up here. So it's just been this kind of regular decline in population sizes. These open circles are the number of populations that were counted for that year to determine if populations are declining or not. So they started out back in the day not counting very many populations. So I guess it kind of makes you think that like this is a little more relevant or solid data. But in total, they looked at 936 populations, and you can see these more recent trends they're still trending outward. And amphibian populations that are healthy can decline really rapidly. It's sometimes year to year population numbers will go down by half. Excuse me. So this could be helpful to monitoring conservation. These animals are sensitive to degradation. A lot of the declines in population size or number are enigmatic. They're called enigmatic declines. Just means there's no known cause for why they're happening. That's the case for, they estimate, around 48% of declining amphibian populations. No one knows why it's happening. So traditionally, yep.
You think the no rain kind of a situation is going to cause even more of a population decline? This year would be spectacular to get results for, simply because we've had such a low rain and no snow and less vernal pools, I think, compared to the last few years.
It's very possible. I mean, I guess it would depend on how many of members of the population are getting picked off by predation or disease, because even if they miss 1 year of breeding, they'll come back the following year, for example. They live a while. So
the impact would be on recruitment then. So this year's population gain will be minimal.
Yeah, that's true. But it's not like they die after they lay eggs, I guess is what I'm saying. So we're not going to lose an entire swath of the species because for 1 year they can't breed. So traditional large census counts of animals can take years to complete. So you might not be able to get a good idea of the health of a population if that's the only way you're doing it. So you could use microsatellites as well as a baseline and a marker to monitor future fitness of animals because they do evolve rapidly. You could get an idea of what's going on now versus what's going on 5 years from now, which we could actually do because a lot of this is from 5 years ago. So that would be interesting to take a look at in the same populations. Another thing to think about is that genetic structure of closely related species in the same landscape can be inferred from more populous species. So studies have been done where they took a common species of salamander in this case and inferred how the populations of really similar, like other Ambystoma species, are faring. And in Massachusetts alone, there are a number of threatened species. These blue-spotted, marbled, and Jefferson salamanders have the same habitat type, but just aren't seen nearly as often as spotted salamanders. So it's hard to do studies on rare animals, and also you don't want to really put a threatened species through the stress of being handled. So you can kind of infer their structure and their health from the common species. That's something you would want to do. Then you can always use microsatellite results. Oh, that's what I said. And so that most of that work comes from a Manier and Arnold article in 2005. I think there could be made some arguments against going that way because similar species in the same habitat are also going to be competitors. So, I'm not sure how well that would hold up in the long term as far as not monitoring threatened species at all and only looking at common species.
Yeah, not to mention difference in